Hi everyone, my name is Hakob Tamazyan, and I am a senior machine learning engineer at Krisp. And today I am excited to talk a little about image processing and also video segmentation. So let's get started. This is my rough outline. First, we'll talk a little about deep learning for computer vision. And I will give you some real-life examples, applications. Then we will dive into video segmentation, and we will have a more detailed discussion about this specific topic. And eventually I will give you a live demo. So deep learning for computer vision. For over the past decade, the field of computer vision, as you may know, is constantly shifting from statistical models to deep learning neural networks. Yes, there are still some challenging problems to solve. However, deep neural networks are achieving state-of-the-art results from a lot of them. And let's to introduce you some of those tasks. First and the most basic one of them is image classification. So what it basically does, you give to your model the image of an object, like this one, feed it to your model. In our case, model is a neural network. And also your model's output should be, for this example, dog, as it categorized your image to dog class. And in this case, when it's image of cat, your model should predict cat. So it's one of the most basic, the most popular tasks to solve from computer vision. Let's a little talk about object detection and segmentation. Sorry. So, what is object detection? Object detection goal is to locate where in the image your specific object is. Where is its location? And for most cases, it gives you the bounding box where it says where your target object is. And in case of image object segmentation, it identifies all the pixels in your image that belongs to your target object. So if you give this kind of example to our neural network, it may give us this kind of output, where in our case, it gave us both bounding boxes and also segmented objects, like people, the horse, umbrellas, and so on. One of the most popular application in nowadays is self-driving cars. They have got a lot of hype for the last several years, and it's not a secret that object detection and segmentation is considered the one of the most important features for making self-driving cars. So when the car sees its environment, it should recognize and locate road signs, crosswalks, pedestrians, lanes. So it should understand just looking tweets around what is going on. And our next one is depth estimation. What is depth estimation? Depth estimation main goal by getting RGB image in to this space, and for each pixel it gives you those pixels depth, like it measures these pixels distance from you. So for like in those two examples, it gave us the distances for all those pixels. And also let's pay attention to the fact that depth estimation also is very important problem to solve for making self-driving cars. So that was all about deep learning for computer vision. It was like an introduction and some examples. And let's dive into video segmentation. So at Krisp, we have computer vision team, which is working on video segmentation and the background changing problem currently. So basically what it does during different conferencing calls, your meetings, interviews, when you don't have your appropriate environment to connect to those meetings with your video, this video segmentation task solves this problem for you. So it changes your background, your environment with a more appropriate one. So this is overall the video segmentation problem that we want to solve. First, let's talk a little about what kind of networks there are that are good for video segmentation. There are some of them, like UNet or feature pyramid net-like networks. So by looking at their structures, you can see both of these neural networks have their encoder and decoder parts. Also, let's notice they have skip connections too, and those skip connections actually play a huge role for getting high accuracy here. So also let's notice one more thing. In problems like segmentation, creating your dataset is very time-consuming process. Actually, you should annotate each of your pixels in every picture. So it's a common a method for initial steps to use some already pre-trained classification deep neural networks and do some transfer learning on those nets. Okay. And overall, the whole our pipeline has this kind of structures where from a video we split it into frames, pulse it from with some pre-processing, then feed it to our neural network, get its output mask, and finally do some post-processings on them. So at first sight, it may seem a little not so hard problem to solve. However, when you are starting working on it and trying to get good results, you will see some challenges to overcome. And today I want to share, to talk about some of them. So one of the challenges is that when your object is holding another object, in this person where she holds a gift, in ideal case, you would like to segment this gift to this object too. However, when you are training a human segmentation network, it will segment just the human part. Instead, you would like to get the gift part too. Actually, it's not so trivial task to solve, and it requires a lot of research to do so. The next one is when you're trying to solve a video segmentation problem, which we will be used during conferencing calls. First, it should work in real time. And in our case, it also will work on CPU cores. So it becomes essential problem to solve that, to create a very fast performing neural network that overall it will perform very fast, and you must you will automatically to try to speed up your network inference specifically. Yes, there are a lot of techniques to solve this kind of problem, like knowledge distillation, automatic model compression, like weight pruning, or the model quantization. And today I will talk only about models quantization, what it does and how it does. So model quantization is specifically its main goal is to speed up your model's inference time. As you may know, by default, all the operations of your neural networks are float point operations. So the quantization converts all those float operations into integerate operations. And how it does, for each parameter of your model, its XF parameter, by using shifting and scaling operations, it converts those values into integer values. So also there arises another problem that during those conversion, obviously your model's accuracy will reduce. So what quantization algorithm does, for each your model's parameter, it finds the best, the optimal shifting and scaling values that will change, that will decrease your model's initial accuracy as little as possible. So during different experiments on different networks, this technique actually speeds up your network's performance 2 to 3 times in average. And due to this conversion, also it will reduce your model size by 4 times because it converts float 32 into integer 8. According to my this outline, now I should demonstrate you what we have done at Krisp from video segmentation. But instead, this whole time, actually, simultaneously, I was doing it because in this call, I'm connected with a virtual camera, which is using the video segmentation, the background change that is using the result of our team's work at Krisp. Actually, that's all that I has prepared today.
Thank you very much. So can you put a present on your hand so we can see how it
works? Okay. I will even turn off the screen sharing now.
Okay. This looks very well. So if you can put something on your hand, like...
this problem is not solved yet, actually.
Okay. Well, okay. So we have seen a couple of pixels from the pen and then...
Right.
Nice. If attendees have questions, please put them in the Q&A button on Zoom. But before you do that, I have my own question. So I have seen in many works that are working with video stream that there is a problem that on the neighboring frames, your model can act very differently.
Right.
So you know the problem, right? So on one,
like light changing may occur, or some tiny change can actually give your models the whole different output.
Exactly. And my question is, when you do the processing right now, do you use only one frame? Because your architecture, I think in one of the slides showed that you split it into the frames and pass each frame individually into the UNet type network, right? Do you use one frame only, or you use neighboring frames together to get this smoothing effect or something like that, or passing single frame is enough?
Actually, that's a great question. First, we have faced this problem, and currently we are using also neighboring frames that will give our networks more consistent output. And also with it, we are doing some additional processing for reducing those changes between neighboring frames.
So even in pre-processing, you make sure that there is, I see.
Right.
That's a nice idea. Yeah, sounds good. We have a few more questions. So Kevork Sulahyan asks, did you usually train models using transfer learning? How about training from scratch? So did you have anything to transfer from in UNet?
Actually, here that I was talking about transfer learning, it was mainly about your first steps. It will be a great experience to start with transfer learning, because first you need a huge amount of data to get good results. However, if you don't have if you have enough data, you can actually try to do some some trainings from scratch. Yes, we are doing training from scratch.
Interesting. There is another question from Arsen Yeghazarian. He asks, what libraries do you use for quantization, if you use any libraries, and what type of accuracy change you get from that?
And about quantization, our main deep learning framework for background change is PyTorch, and we are using mainly quantization there. And what about accuracy changes? Yes, there are a lot of techniques that will reduce your accuracy loss after quantization. And now currently the loss is very faint, like you don't even notice that this model will actually perform bad than your initial one. And so my answer is that when you are using the quantization with appropriate techniques, it will actually not harm your model.
I see. So one more sub question to this. Do you use post-training quantization only, or you also use quantization during training?
Actually, we use both of them, and also they are the other techniques too that I didn't prepare to talk about them today. Yes, we are using post quantizations and both and quantization over training like techniques, and some other techniques too.
I have a question with just continuation. During training, do you use floating point or integer quantization?
During training, we are using float. At first, we are using float point operations.
Okay, thank you.
For getting initial high accuracy, and then starting on quantization techniques.
Okay, thank you.
We are getting more questions. Yeah, we have time, so it's okay. Levon Khojayan asks, your current demo, right? Does it run on CPU right now, or it's on GPU?
It's running on CPU on my device right now.
Perfect. And another question, does your person segmentation model do person liveness check? If you hold up a photo of a person, will the model detect? This is a question from Rafael Darpinyan.
I think it will detect. It's actually very hard to detect if it's a person's image or the real life person's image. I think we didn't do such experiments, but I think it will detect. Okay, so it will work as a real person. All right. Interesting. And I think I have one more question. Can you, obviously, I know that it can be a trade secret for your company, but if you can tell anything about how you collect training data, because if you talk about denoising or improving the speech, removing the noise from speech, you can basically generate this type of data, right? You can you can have clear recording and add all kinds of noises. And
my understanding is that it should be harder for background removal or human detection. So
Yes. Actually, what we are doing, we are not just collecting the data from the one source. We are using different sources, and also we have our own team at Krisp that is working on it too, specifically for data collection.
I see. So some people are sitting somewhere, changing background, recording. I can imagine. Okay, let's see if we have any more questions. I think I checked all the channels and looks like we have no more questions. So thank you very much for this presentation.
Thank you
This
too.
was quite interesting.